Hi everyone. So we'll start with our next topic, that is your first order reaction. We have already completed your zero order reaction, right? So from this video we'll be starting your first order kinetics, first order reactions. First order reactions. Just remember, like your zero order reaction, the first order reaction also will just do these kind of reactions. This everything will be applicable for only these kind of reactions. And what will be the rate of reaction? The rate of reaction of R will be equal to your Ka raised to the power 1. In zero order, do you remember, it was equal to your 0, but here it will be R equals to Ka raised to the power 1. It means as your concentration of A is increasing, your rate is also increasing. As your concentration of A increases, your rate of the reaction is also increasing. Like, see through the graph. Rate is increasing, concentration is increasing, then rate is also increasing. Okay. So similar to your zero order reaction, you remember in zero order reaction we got a equation A is equals to A naught minus KT. Here also for first order reaction we'll go through the integrated rate law. We'll go through the integrated rate law. What does your integrated rate law means? Same things you are doing here, and we'll come to a rate law for the first equation, first order reaction. Integrated rate law, always applicable for only these kind of reaction. A is giving you product. And what is the integrated rate law? So your rate will be equal to your K A raised to the power 1. This is my first reaction. Also my rate equals to minus 1 by 1 dA by dt. That's your second. Both are rates only, we can compare them, right? Equate both of them. What will you get? Minus of dA by dt will be equal to your Ka raised to the power 1. If I just shift my t here with a minus sign, dA equals to minus of Ka dt. Then what was the next step? Like, shift your A here. So your dA by A equal to your minus of K dt. Now what do? We integrate on both the ends, integrating both sides. Integrating both sides. So when your t is equal to your 0, your A will be equal to your A naught, and when your t equal to your t, your A will be equal to your A. This is your initial concentrations and this is your remaining. Initial and this is your remaining. Now what do? We after integrating, what do we get? Because this is dA by A, will get log base E of A from your A naught to A, and here you will get minus of K T minus 0. So what did you actually got it? Log base E A minus of log base E A naught equals to minus of KT. And what will be your final equation? Log base E of A will be equal to log base E of A naught minus of KT. Similar to your, this is your first order reaction. First order integrated rate law. How will you remember? Just remember, in the zero order reaction what we used to do, A is equals to A naught minus KT, right? Here and here you put log base E. This is your integrated rate law of a first order reaction. Now this can also be written in many forms. Okay, so if I want to convert it into base 10, converting into base 10, like log base 10, what will you get? 2.303 log base 10 of A will be equal to 2.303 log base 10 of A naught minus of KT. Right? Now just do one thing, divide this full equation by 2.303. Divide by 2.303 and what will you get? Log base 10 of A will be equal to your log base 10 of A naught minus of KT upon 2.303. This is your second equation which can be used. This is my second equation which we can use it. Okay. So if you want to draw the graph, how will you draw the graph? Y is equals to mx plus c, right? So this is my y, this is my c, and this is my m and x. This is my m and t is my x. So how will you draw the graph? If I want to draw the graph, how will I draw the graph? What is in y axis? Log base 10 of A. What is in my x axis? 10. Where is the intercept? The intercept is somewhere here only. Log base 10 of A naught. This is my log base A naught. This intercept, and your tan theta. Slope will be equal to your tan theta, and this will be equal to your minus of k upon 2.303. This is how you represent your integrated rate law. Log base E A equals to A naught minus KT. Just multiply, convert it into your log base 10. You will be getting log base 10 equals to log base 10 A naught minus KT upon 2.303. Now what will be the other forms of equation, other forms of rate law? Other forms of rate law. Whatever two formulas or two equations we studied which is not usually used in the numericals. What is actually used in numericals? See, we studied log base 10 of A is equal to A or A naught, 1 minute, yeah. Log base 10 of A equal to log base 10 A naught minus of KT upon 2.303, right? First thing which we used to like solve numericals, what is that? Used to solve numericals. In what form we'll write it down? Just write log base 10 raised to the A minus log base 10 A naught equal to your KT. Minus of KT by 2.303. Now can I just simply write it as log base 10 A naught by A? This is my A naught, right? Log base A naught, this is my A. So I can write it as A naught by A will be equal to your KT upon 2.303. Here I am not shifting this minus, okay? I am writing like this. So what will it be? T equal to 2.303 by K log base 10 A naught by A. A naught is initial, A is your final. So this is a third equation which you have got, T equal to 2.303 by K log base 10 A naught by A. What was the first equation? Log base, okay, log E A equals to log base E A naught minus of KT, right? Then we wanted it to convert it into your log base 10. So log base 10 A equal to log base 10 A naught minus of KT upon 2.303. Then what equation we got? T equals to log base 10 A naught by A into your 2.303 by K. Everything is coming from the first equation only, if you see. So this is mostly the equation which we use to solve the numericals. Now we already know this particular thing, right? Log base E equal to log base E A naught minus of KT, right? Now, can I write it in this fashion, this particular thing? Can I write it in this fashion? Log base A by A naught equal to minus KT. I can write it like this, right? Minus AT. Now, if I want to remove the log, what will I write? Exponential minus of KT. Exponential minus of KT. Now, just cross multiply it. A is equals to A naught E minus of KT. So, this is also another form of equation how we can write it. This is the exponential form. A is equals to A naught E minus of KT. Okay, so there are four things from which we can use in this fashion. And if you want to draw the graph from this particular thing, what will you write here? The concentration of A. Here you will write time. Your graph will look something like this. And A is equals to A naught E minus of KT. So these are the 3 or 4 kinds of ways in which you can represent your first equation. Now how will you write the half-life of the equation of this particular thing? Maximum times, no, like 90% of times you'll be using this formula. 2.303 by K log base E, log base 10 A naught by A. Let us write the half-life of the reaction. We'll be writing half-life of the reaction. We know by a formula what is half-life. When T becomes T half, your A should become as A naught by 2, right? We studied already in your zero order reaction. Now according to a formula, T equal to 2.303 by K log base 10 A naught by A. So what will be T half? T half will be equal to your 2.303 by K log base 10 A naught by A naught by 2. Now this 2 will shift in the numerator. T half equal to your 2.303 by K log base 10 2. What is log 2? Log 2 is, I guess, 0.3. So T half will be equal to 2.303 into your 0.3 divided by K, which will approximately come out to be 0.693 divided by K. So what is your T half? So from this particular thing you have got T half will be equal to 0.693 by K. This is your formula. So, and what was your T half in your zero order reaction? In your zero order reaction, the T half was A naught by 2K, I guess. A naught by 2K, right? Yeah, A naught by 2K. So it was depending, in zero order reaction, it was depending upon the concentration of A, right? But here in first order reaction, it doesn't depend upon the concentration. Okay? Does not depend upon the concentration. So now half-life you have done. What will be the exactly your half-life is done. What will be your lifetime of the reaction? Lifetime of the reaction will be T is your T lifetime, and your A has become 0 here, right? Why? Because your full reaction is completed, right? So final concentration is 0. So T lifetime will be equal to your 2.303 by K log base 10 of A naught by 0. Right, and T lifetime we don't know. We like anything by the power 0 is like you cannot solve it. This is becoming actually infinite. So what does it mean? First order reaction is never completing. First order reaction is never completing. Okay, it will complete at infinite time only. That's what your first order reaction is. Okay, so quick revision of first order reaction. I think then we can directly switch to your questions, because graph things we'll be doing in a together in a single video for all the first order, second order, third order and nth order kind of reactions. Okay, so revision. What is your first order reaction? First order reaction means K is giving you product. Here your rate is equal to Ka raised to the power 1. And what all formulas you got? First formula was log base Ea is equal to log base Ea naught minus of Kt. In terms of 2.303 log base 10, what will you get? 2.30. Okay, just forget about 2.303. We'll just directly write what we got. We'll write log base 10 of A will be equal to your log base 10 of A naught minus of Kt upon 2.303. 2.303. Third one, what will you write? A equals to, how did you get this thing? A naught E minus of Kt, like we just took the anti-log on both the ends. And what was your T half? T half was equal to 0.693 by K. And what is your T infinity? T infinity is, T lifetime is your infinity. Okay, these are all the kind of formulas which we need to write. And now let us directly do your questions. Just remember what formula you need to mention, you need to use is T is equals to 2.303 by K log base 10 of A naught by A. Log base 10 A naught by A. This is the formula which will be using maximum number of times. So let us do some questions from first order reaction. Okay, the first question is telling you, in a first order reaction, the concentration of reactant decreases from your 800 mole per decimeter cube to your 50 mole per decimeter cube in 2 into 10 to the power 4 seconds. Find the rate constant. What do you need to find? You need to find the rate constant. Now I told you one formula to use. I am giving you 4 options. 2.1 into 10 to the power minus 4 second inverse. Second is 2.1 into 10 to the power 4 second inverse. Third one is 1.37 into 10 to the power minus 4 second inverse. D is 1.37 into 10 raised to the power 4 second inverse. I told you one formula to use in all the numericals, like maximum cases. So T equal to 2.303 by K log base 10 A naught by A. What do we need to find? We need to find your K, right? Just cross multiply. K equal to 2.303 by T log base 10 A naught by A. What is A naught? Your initial concentration. A is your final concentration. So K equal to 2.303 by time. What is the time given? 2 into 10 to the power 4. Log base 10. What is A naught given? Decreases from. So this is my A naught and this is my A. So A naught is 800 divided by 50. What is 800 divided by 50? 5 ones are 5, 3, 5 6 are 30. Log 16. So log 16 I can write it down as 2.303 by 2 into 10 to the power 4. Log 16 I can write it down as 4 raised to the power 1 minute. 4, 8. 2 raised to the power 4 I can write it down like this, right? How will you solve it? K equal to 2.303 upon 2 into 10 to the power 4 into 4 into log 2. What is your log 2? 0.3. So what will you get? K equal to 2.303 upon 2 into 10 to the power 4 into 4 into 0.3. Just use your calculators and check what will be the answer. Let me also check. See, 2 2s are 4. So this will be 3 2s are 6. 2, 6, 4.606 into 0.3. 4.606 into 0.3. 1.3 into 10 to the power minus 4. 1.37 into 10 to the power minus 4. This thing will be the answer, right? So this is how you do the questions. If you have understood zero order reaction, first order will be quite easy because you know all the formulas. Everything will be formula based. The second question. Second question is telling us a first order reaction is 20% complete. A first order reaction is happening and it is 20% complete in 5 minutes. Write down what all is given first. Find the time in which it is find the time in which it is 60% complete. Your options are 10 minutes, 20 minutes, 30 minutes and 40 minutes. So what all things are given to you? First order reaction is there, 20% complete, 20% complete. Let us assume your A naught was 100. 20% complete means how much is left? 80 is left, right? And what is the time given to you? 5 minutes. Second case, it's given A naught equals to 100. A is your 40. 60% complete means 40 is left. You need to find the time. Write the same equation. T is equals to 2.303 by K log base 10 A naught by A. Substitute all the values. You need to find prime. Yeah. 5 equal to 2.303 by K log base 10 100 by 80. Here also you write time equal to 2.303 by K log base 10 because you don't know the time here, right? Initial is 100, next is 40. Next is, yeah. So this and this gets cancelled. Now what do? We do this reaction like second divide by 1. We are doing now second divide by 1 to find the value of T. What will it be? T divided by 5 equal to your 2.303 by K log base 10 100 by 40 divided by 2.303 by K log base 10 100 divided by 80. This and this gets cancelled. What is left? t by 5 equal to your log base 10, 100 by 40. Let's do this thing. We'll write like this. Ten by 4 divided by log base 10, 10 by 8 here, right? How can we write this thing? T by 5 equals to log base 10, 10 minus of log base 10, 4. And here you can write log base 10, 10 minus of log base 10, 8. This is 1. Log base 10 raised to the power 10 is 1, right? Just removing this portion. One minus log base 10 raised to the 4 divided by 1 minus log base 10, 8. For 2 cube, I can write 8 as 2 cube, and this I can write 2 square, right? I can write this as 2 square, I can write this as 2 cube. So t by 5 equal to 1 minus 2 into 0.3, 1 minus 2, no, 3 into 0.3. T by 5, 1 minus 0.6, and here it will be 1 minus 0.9. 1 minus 0.6, 0.4. 0.4 upon 0.1. Point and point gets cancelled. So 4 into 5, that is your 20. So time is your 20 minutes. Time will be your 20 minutes, okay? Next question. Okay, next question is telling you A is giving me product, and this is your first order. Already given, this is your first order reaction. And they are telling the concentration of A changes. The concentration of A is changing from 0.1 m to 0.025 m in 40 minutes. What you need to do? You need to find the rate of reaction when concentration of A is 0.01 m. And what are the options given to you? 2.79 into 10 to the power 4, 3.47 into 10 to the power 4, 2.79 into 10 to the power minus 4, 3.47 into 10 to the power minus 4. What is given to you and what you need to find? We need to find the rate of the reaction. We need to find the R, right? When concentration of A is this. The concentration of A changes. I mean, A naught is given to you as 0.1. A is given to you as 0.025. Time is given to you as 40 minutes. What you need to find? You need to find the rate of the reaction when concentration is this much. K is not given to us, right? They are telling us you have to find the rate when the concentration is 0.01. Okay, this is easy. Just find K from all these values given. Apply direct formula. We know K equal to 2.303 by T log base 10 a naught by a, right? K equal to your 2.303 by 40 log base 10 0.1 upon 0.025, and this one will be 4. 2.303 by 40 log base 10, this one will be 4. I can write it as 2 raised to the powers 2. So K equal to your 2.303 by 40 into 2 into 0.3. When you solve all this thing, I think so it will come, let me check, 2.303 multiplied by 2 into 0.3, 2.303 multiplied by 2 into 0.3 divided by 40 will be 0. This one will be 0.034545. Okay, if I want to shift my decimal points here, 1, 2, 2 decimal points I need to shift. What will I write? 3.45 divided by 100. 3.45 divided by 100. Now we know rate equals to Ka raised to the power 1, right? And what is the concentration of A? They are telling us 0.01. So K we know 3.45 upon 100 into your 0.01. How much it will be? 3.45 into 10 to the power minus 4 will be the answer. Okay, last question. Last question from your first order. If for first order reaction, if for your first order reaction your K is 6.93 into 10 to the power minus 3 minute inverse, what do you need to find? You need to find A, your T half, B, your T 1/3. What does 1/3 mean? Reaction is completed on 1/3, 2/3, and then T 3/4 you need to find. See, T half is very easy. T half, we know the formula. T half is equals to 0.693 by K. What is K here? 0.693 divided by 6.93 multiplied by 10 to the power minus 3. I can write this as 693 into 10 to the power 3 minus 3. I can write this as 693 into 10 to the power minus 2, right? And 10 to the power minus 3 is already present. This and this gets cancelled. What is left? 455 plus 5. 10 to the power 2, right? This is easy. How will you find T raised to the power 1 by 3? What does it mean actually? 1 by 3. It means 1 by 3 is completed. 1 by 3 is completion is happening. And how much is left then? 2 by 3 is left, right? So, use the formula T equal to 2.303 by K log base 10 A naught upon 2 by 3 A naught. And what will you get? 2.303 by K log base 10 3 by 2. Right? So, if I want to solve this thing, 2.303 by K is already given to us, right? 6.93 into 10 to the power minus 3 log base 10 of 3 minus of log base 10 of 2. And then you can solve it. Similarly, do the other two. The other two is telling us when T is your 2 by 3, how much is remaining? 1 by 3, right? So, your T equal to 2.303 by K log base 10 A naught upon A naught by 3. by k log base A naught upon A naught by 4, right? So only these kind of reaction questions will come for your first order reaction. It's very easy. Let's study some examples of first order reaction. Examples of your first order reaction. And what will be our example? First is in your nuclear physics. In your nuclear physics, there might be any radioactive decay equations given to you, which is your first order reaction. It never completes. That's why. Radioactive decay. Next reactions can be your growth and decay of bacteria. Growth and your decay of bacteria. Third reaction which can be given is inversion of cane sugar. Inversion of cane sugar, and it is written as C12H22O11 plus H2O in the presence of H plus medium is giving you glucose plus fructose. Both have the same formula. Then what thing is there? Inversion of acidic hydrolysis of ester. Acidic hydrolysis of ester. CH3COC2H5, when you add water in the presence of H plus, what will you get? Acid plus alcohol. Acid plus alcohol. This is also your first order reaction. Next examples you can take is dissociation. There are many examples. Dissociation of N2O5. And what will it be? 2 times of N2O5 is giving me 4NO2 plus O2. Last example you can take is dissociation of H2O2. And what will it be? 2H2O2 is giving me 2H2O plus O2. These are some examples of your first order reaction. Next, very important points for your first order reaction. Sometimes directly the question comes from this topic. Two things you need to remember. Important point. Two things. Here in first order reactions only we are talking about. T 75%, whenever your T 75% happens, that will be equal to 2 times T of 50%. First thing you need to remember this. Next is T 99.9% will be equal to your 10 times T of 50%. If you want to remember it, well and good. If not, it's fine. You can prove it also. First one, how will you prove it? The first one, calculate T of 75% and 50%. What will it be? 2.303 by K log base 10. What is your initial concentration? Let's take 100. How much is left then? 25. Right? T for 50%, how much it will be? 2.303 by K log base 10. 100 upon 50. Just do 1 divided by 2. So T of 75% upon T of 50% will be equal to, these both gets cancelled. Log base 10 is left. Log base 10 4. Log base 10 2. So what will it be? T of 75% by T of 50%. I can write this as 2 log base 10 of 2. and here also log base 10 of 2. This and this gets cancelled. So what is left? T 75%. Now we have got our answer. T 75% will be equal to twice of T 50%. The second case, how will you prove the second one? T 50%, you already know this thing, okay? So just save this equation. T 99.9%, which means how much is left then? 0.1% is left, right? 2.303 by K log base 10 of 100 upon 0.1. This is my third equation. So just do 3 divided by 2. In third, this and this will get cancelled. So what is left? Log base 10 of 100 upon 0.1. %, divided by T 50% equal to your log 10 to the power 3. I can write it down, and here I can write it down log base 10. I think it will be 2, right? So this will be T 99.9% by T 50% will be equal to 3 log base 10 of log base 10 divided by log base 2. Log base 2 is your 0.3. So 10 log base 10 is 1. So T 99% equals to 10 times of T raised to 10 times of T 50%. This is how you prove both these things. Okay, so our first order reaction is also complete. Please revise all these things because second and third order is very different from all these things, from 0 and first order reaction. Okay, so that's all for your first order reaction. Thank you so much.